All right. What we're looking at in this section is that we want to look at how do we evaluate piecewise functions. So here it is that we have a function here that reads. So the function reads, given a of x is equal to the absolute value of x, right here, absolute value of x minus 8, if x is less than or equal to 6. So we are seeing the conditions, right? So a of x is equal to x minus 8 if x is less than or equal to 6. You have to pay attention to that. A of x is equal to 2x minus x squared if x is greater than -6 or less than or equal to 1. We have to pay attention to that as well. Also, a of x is equal to -4x plus 7 if x is greater than 1. All right, so whenever you're doing the piecewise functions, you have to look at the conditions that we have, and then we're going to be functioning within that domain, right? So these x intervals or values, range of values that we're getting are actually the domain values that we will be looking at within context of each of the functions. For example, the question says evaluate. So we're going to be evaluating or find the value of a of 8. A of 8, I have to think about this number 8 right now. 8 would fall in which one of these categories right here? 8, as you could see, will fall in the greater than 1 category, which means I have to focus on this function. For example, I'm focusing on a of x is equal to -4x plus 7, because we're saying that 8 will be a number greater, 8 is a number greater than 1, so we'd have to focus on this as we try to find the value for a of 8. Let us do that. Whenever you're evaluating a function, basically what we're doing, we're substituting the letter, the number for the letter in the function. So -4 times x will mean -4 times 8, and then we're going to be adding 7. -4 times 8 is -32. And when you add 7, we're going to be left with positive. We're going to be left with, should say, -25. Sorry about that. So that would have been the correct response for that answer right there. Let's go on to number 2. In number 2, we want to evaluate a of 1. Which one of these a of 1 would have fell into? It's not less than or equal to -6. It's not greater than 1, but definitely it is equal to 1. So it's going to be, we're going to find it in this section, in that function there, right? So we're going to be using that function in the middle to evaluate that. So let's write the function. A of x is equal to 2x minus x squared. And then from this, we're moving from greater than -6 to less than or equal to 1. So we're going to be doing a of 1. So 2 times 1 minus 1 square. 2 minus 1 is. But the next one, a of -7. -7 will be a number in the category of less than or equal to -6 here. So on our number line, anything left of -6 or equal to -6 will be a part of that domain. So let's write this. So a of x is equal to the absolute value of x minus 8. Bear in mind, all absolute values are just positive numbers, because absolute value is actually the distance from 0. And a distance is always a positive number. So if we get a negative number, remember, it's the absolute value of that number we're looking for. It is always going to be positive. So we're going to be doing a of -7. So a of -7 would mean that -7 will go where the x is. And let us finalize. I'm looking at the absolute value of -15. And the absolute value of negative 15 is 50. So we're looking for that response. Let's continue. Now we're looking at A of negative 3. A of negative 3. So A of negative 3 would be in the second category here, right? Because negative 3 is between greater than negative 6 and less than or equal to positive 1. So it's in that category. So we're going to write the second function. So A of x is equal to 2x minus x squared. So if I'm doing A of negative 3, it's going to be 2 times negative 3 minus negative 3 squared. This is negative 6. That's a negative. But when you square, see, the thing is, we don't want to mix up this. When you square negative 3, you will get a positive number. So it's just 9. So this is just negative 15. So A of negative 3 is negative 15. You want to graph each function. Look out for the next video coming. See you next time at Daily Maths Concept. Bye-bye.